Okay, in this lesson we are going to learn about power and efficiency. Okay, the first thing we'll be discussing the difference between power and work done. Though related, power and work done are different from each other. I'll use an analogy. Alex and Ben were each given 100 paintings to hang. However, Alex is able to complete the task in 30 minutes while Ben completed his task in 40 minutes. Who do you think is more able? If they are both given 60 minutes, who do you think most likely is able to hang more paintings? We'll keep this in mind and we'll see how this scenario works out with power and work done. So the power formula is power is equals to work done divided by time. The SI unit for power is watts. And the base unit for power is joules per second. So it's joules per second. So power is equal to work done divided by time. What does it mean in terms of layman? Imagine two persons having the same mass, A and B, walk up the slope at the same time. So you have these two persons and they walk up the slope at the same time. As you notice, B reached the top of the slope first. So the question is who did more work and who has more power? Think about it. A and B actually had the same amount of work done. However, B has actually more power. Do note that A and B must be of the same mass. It is because then at the top of the slope, then both A and B would possess the same amount of gravitational potential energy, which is dependent on mgh. So the mass is the same and the height is the same. So therefore they must have the same gravitational potential energy. And this led to them having to have used or inject the same amount of work done to enable them to walk up to the top of the slope. However, since B used less time to walk up the slope and using the formula of power equals to work done divided by time, so as you can see, if it's a smaller amount of time, you find that your power becomes bigger. So that means that B used shorter amount of time and doing the same amount of work. That means that the power of B is actually larger. Though they did the same amount of work, B is considered to be more powerful compared to A as he is able to reach the top of the slope first. So this is a simple way to look at the concept of power. So notice that the first case, Alex and Ben, you find that Alex is able to complete his task in 30 minutes while Ben completes 40 minutes. So Alex is more able or more capable in that sense. Okay, but anyway, what if the mass of A and B is different? So another example to help illustrate. So if there are different mass, if a person of 50 kg climbs a vertical ladder and has a power of 100, what is the height that he has climbed at the end of 1 minute? And we assume that all his power is used to increase his gravitational potential energy. So power equals work done divided by time. And the work done is used to increase in terms of the gravitational potential energy, and his power was 100. And time in this case is 60 because we use seconds as the reference. Okay, so 1 minute is equivalent to 60 seconds. Bring it over, so you get 6000 equals to mgh. And in this case, h is equals to 12 meters. So we can say that at the end of 1 minute, he has climbed 12 meters because his power is 100. Okay, what if another person of 80 kg does the same thing and is meaning they're able to climb 12 meters in 1 minute? Then can you able to calculate his power? Same thing, you use the formula. Okay, substitute in this case, since we do not know the power, okay, but we do know the increase in gravitational potential energy, which is 10 times 12, but the time round the mass is 80. So by solving this, you find that the power is 160 watts. So in this case, you find that the mass of these two persons is different, but if they are able to accomplish the same task, able to climb 12 meters in 1 minute, the second person, which is heavier, is actually more powerful in that sense, because even though it's heavier, it's actually able to do the same thing as someone that's lighter. Another scenario, two toy cars X and Y of different mass starts from rest and increase their velocity. At the end of 5 seconds, the velocity of X and Y are found to be 6 and 8 respectively. Then determine the calculation which car has a higher power. we assume that there's no energy loss to friction. Okay, so it might be tempting to just say that Y is having more power because it's faster, but let's just calculate. So power X is equal to work done divided by time, and the work done is used to increase in kinetic energy in 5 seconds. So using the formula half mv squared of Ke, so you substitute in the values, you find that this would be the power 14.4. You do the exact same thing for Y, and substituting the value, you find that this time around again the mass is different, 4 and 2, and your answer is 12.8. So in this case, the power X is actually larger even though it is slower. It is because again the mass of the object is larger, and to be able to achieve this speed takes more power to do it. So high power versus low power. A high power object compared to a low power object can either accomplish the same work done but in a shorter amount of time, or given the same amount of time is able to generate more work done. To put in perspective, an object having a power 1 watt means that it can generate or use up 1 joules of energy for every 1 second. Okay, you notice that of course this light bulb has this 75 and 40. It generally indicates the brightness, but what does it really mean? Okay, it actually this 75 and 40 actually display how much energy it will use per second. For example, 75 watt means 75 joules in 1 second, and you can generally expect that 75 watt light bulb to be brighter than 40 watt light bulb. So some other examples of power rating of other common electrical appliances. Here are some of the more common electrical appliances. So you have fans, that's roughly about 70-75, but you find that air conditioner uses quite a lot, which is in the range of 1000 plus. Your TVs in the range of 100 plus. Okay, and of course lamps, they have about 10, 40s, and so on. Other things such as cooking device, okay, you find that it's also pretty high. Some have thousands, some is hundreds, and some miscellaneous. Okay, so this gives you some idea that different electrical appliances utilize energy in different amounts. Please subscribe and support my channel. For my other physics video lesson arranged according to topics, please visit my blog at boringphysicsteacherswordpress.com. You can subscribe to my channel to be informed when I upload new physics video lessons. Thank you.